solve logarithmic equations. So you can see each equation here is a log equation because it has a log in it. And the variable that we're trying to solve for is inside the log function. So that's what qualifies it to be a logarithmic equation. So the way that you do these is you want to combine the logs into one log and then isolate that log and then convert it into exponential form. Those are the steps that you're going to do. So the first step is to combine the logs. In this case, we only have one log, so I'm going to isolate it. That's the second step. And the way I want to get rid of the 3, so I'm going to divide both sides of the equation by 3. And that's going to give me log base 3 of x is equal to 4. Now, this just says that to put it in exponential form, the log is the exponent. This is the exponent on 3. So what that's equal to is x, right? So we have 3 to the 4 is x. This is exponential form of this log equation. Now, 3 to the 4th power, well, that's just 3 squared times 3 squared, or 9 times 9, which is 81. So we see that x is 81. All right, in the next problem, again, we only have one log, so the first step of combining the logs is not needed. We have a single log, and the base here is 10. Okay, that's understood to be 10. So the log is the exponent, and the base is 10, so 10 squared is 2x plus 1. So 2x plus 1 is 10 squared, which of course is 100. So 2x plus 1 equals 100. And so 2x, I'm sorry, is, if I subtract 1 from both sides, is 99. And then I'm going to divide both sides by 2. And so I get that x is equal to 49 1/2. Or you could just say 49.5. Okay. In the third example, now you see we have more than one log. Make sure that the base is the same. You can't combine them if the bases are not the same. So I'm going to add this log to both sides. So I'm going to add log base 2 of x to both sides of the equation. And that gives me log base 2 of 4x plus log base 2 of x is equal to 2. So now I've got the logs grouped together. I'm going to combine them. They have the same base, so and we're adding. So this is going to become log base 2 of 4x times x, which is 4x squared, and that's equal to 2. Let's draw a line here to separate that. Okay, so now I'm going to want to put this in exponential form. Once you've combined the log and you want to put it in exponential form to get the variable outside of the log. And so this is going to become, the log is the exponent. Here's the base. The base is 2. The log is the exponent, that's squared, and that's equal to 4x squared. Now I always like my x's on the left. So I'm going to go ahead and put 4x squared is equal to 4. And I want to isolate the x squared, so I'm going to divide both sides by 4. And I get x squared is equal to 1. And applying the square root property, I take the square root of both sides, and that gives me x is plus or minus 1. Now, with log equations, you need to check your answer just in case, because remember, logs have that domain where the argument, what's inside the log, has to be greater than 0. So this is no problem. If I plug 49.5 in here, you can see I get 100, 10. What exponent on will give you, on 10 will give you 100? Well, that's 2. So that checks out just fine. And similarly, 81 plugged in here is fine. That's positive. -1. If I plug my -1 in here, I'm going to be taking the log of a negative number, right? 4 times -1 is -4. You cannot take the log of a negative number. So I gotta be careful because you want to sit there and circle the answers and be done. But we get x equals plus or minus 1, but throw out x equal -1 since the domain is greater than 0. I should probably write that better. Since the domain of log of 4x and log of x, that's of course base 2, is all real numbers greater than 0. Okay? There we go. All right, so we throw out -1. So the solution to this, let's see, see where can I write it? The solution to this equation, we don't really have much room here. Let's just say x is equal to 1. All right, normally when you take the square root of both sides, you get plus or minus 1, but we had to throw out the -1. And so just remember, always check your answers to make sure they are in the domain for the functions in your equation, okay?